Hello, all. So, yeah, I forgot about the show tonight. Genius. So, I'm just jumping on here and shared a link in case anybody wants to join. This is a special late edition of Devosh Live, which may have no guests because I forgot about it. But Turfta may be able to join us if he clicks the link. If not, we can reschedule it for tomorrow so that we can get it in before the open source event, which is next week. Because I'd like to see the Makerchip progress before we go off to the show. So if anybody's out there, assuming nobody's out there, we can have questions or just wait until tomorrow. In the meantime, I can show what I've done with the FPGA project since nobody's here right now. So, share my screen. Since the last episode, did some work on the FPGA plus ESP32S3 project. I actually started to schematicize things outside of the stream, and we have a bunch of components that came in, and we have all the power supplies. I actually grafted these from another design, and this is the battery circuitry, which I also took from another design. And so it went pretty quickly when I did that. And then I added a bunch of to-dos down here in the I/O page, which is where the fun starts happening. These are the PMOD headers. This is the FPGA up here. But we need to start actually adding these last pieces. I'm not going to do that on the stream today, but this is just a few more things we need to add. I also updated the layout a little bit and added the components that I added over here. So that's scrolling so good. But yeah, it's the same project or further down the line. So everybody's excited about that. It's moving along. We might have to grow this board a little bigger. Okay. So go ahead and stop sharing. Okay. Yeah, so the agenda is kind of out the window today. It was supposed to be a pretty sizable episode. So let me check if there's anything on the schedule that we can cover right now. Otherwise, we can just postpone the stream after 10 minutes. So Okay, so yeah, all the things that we're going to cover were from other people that were joining. So we'll try to get this rescheduled and get everybody online, and then we can have the pre open source special edition. All right. So I guess we'll see you in the next stream, which is probably going to. Oh, we got Tori. He showed up. Awesome. Let's go ahead and add him to the stage. Hey.
Hello.
I was just about to close out the stream because there was just a short one. I showed off the FPGA project, so if you want to show off.
Yeah, the open muscle flex grid. That's what I was working on.
Yeah.
Yeah, I'd be happy to. Okay. Sorry for the late. I just saw the message, so I just hopped on.
Oh yeah, I'm sorry. It's more my fault than yours.
No problem.
I don't know what got into me today. It's the first time's been on Thursday, and I just completely forgot.
Yeah.
Which is bad.
No, I hear you. I just clocked out the other day because I work a lot on projects like this. I get so passionate, time just I lose track of time. So
yeah, well, I have a day job that does that to me sometimes too.
Yeah, I can show. I'm not sure. I don't have to take too much time, but I'd love to share. You helped me with this project. So
I think it just we can do as long or as short as you want. It's your project, and it's an interesting project. So I guess we could start with kind of the impetus and the story of the project, and then we can show off the current status, maybe demo.
Sure. Yeah, I can do that.
So let me go ahead and are you going to share some assets on the screen?
Yes, I will share mostly probably just the schematic, and then maybe just a 3D render while I talk about the impetus.
Okay. All right. So let me go ahead and make you the main guy on the screen here.
Wonderful.
All right, and then once you add your presentation,
okay, I'm going to share my screen. And entire screen, we'll just share this one. Okay.
All right, let's add that to stage. Good.
Wonderful. So this is the current version. In short, this project was started because there was I watched a video on prosthetic sensors. There's a guy that had no arms, and he had surgery to move the muscles that were the nerves into his pec muscles. And so this college built him these 2 arms, and I thought that was amazing. But the video also said that he couldn't use them at home. And it made me upset. I'm like, why can't? So they literally had surgery on him, and they did this, and it was because this was just a trial, and the company that was designing the prosthetic doesn't allow the tech to go outside of the lab, and so that frustrated me. I thought, well, we live in an advanced age. There needs to be open source prosthetic sensors, right? Yeah. And so yeah, something. And so I'm a guitarist, and I noticed that when I started playing bar chords with my fingers, that the muscles in my forearm would bulge. Yeah, right. And so because holding a bar chord, and I learned, I'm not in the medical field, but the muscles in your forearm pull the tendons to do finger flexion and extension. So my mind said, well, I want to work on prosthetics, and I want it to be open source. And there is data here. And so this was when AI or machine learning was coming out. And the muscles are very difficult. There's multiple layers. But I knew that if I were to use supervised machine learning with some kind of label device, and I had some kind of sensor on the forearm, that I could build a prosthetic sensor. And this is one of the label devices that I created. And so I just needed to correlate them. So that started a 4-year journey where I first needed to test whether or not, because I wanted to use pressure. And there's a reason, because there's a couple of problems in prosthetic technology in general. And one of them is like the sensor placement problem.
Mm-hmm.
And another one, there's multiple, but for sensor placement, I thought if we could have a matrix of sensors around the forearm that was rotationally symmetric, it wouldn't matter where it's at. Just increase the sensor density, and you would touch all of the locations.
Yeah.
So that is what spurred this on. So this is the final. This is probably prototype number 20.
Wow.
And it started off with physical pressure sensors, but now I actually probably have to show on screen because that's another file.
Yeah.
So instead of actually using a piston mechanism, because I was using Hall effect sensors and magnets, and I would have them with springs, a whole bunch of problems, but I eventually created this flex PCB
Okay.
that has two spirals. And so each of these pads is made up of two spirals that don't touch. And then this material is called Velostat. It's a force resistive material.
Okay.
And so when I place this around the forearm, and as long as I have the other piece, it actually measures pressure. And I had to dial in the surface area of these sensor pads, and there was a lot of trial and error for 3.5 years to get the pressure right.
Yeah.
And now we have this PCB,
cool.
Which I think is interesting because you actually helped me with this, because I never had designed a PCB before this project.
Yeah, it looks nice. All the different things, ESP32.
Yep.
Regulator. Looks like you have battery power.
Yes. So I used just a LDO with an EN pin.
Okay.
I had to get the logic for, it powers on when you have USB.
Yeah.
I'm using this Max switch, and it's nice because it has debouncing and it has low quiescent power draw.
Nice.
And then I have a haptic motor that I messed up some boards when I didn't have this protection circuit here. So there was a lot of trial and error there, not having the diode. And
how big is the haptic motor?
It was just a little small cell one.
Okay.
One I got on AliExpress.
I'm sorry? Is it surface mount or through hole?
It's through hole.
Okay.
And it was just a cheap one that has the two wires that you just solder in.
Okay.
And it comes with I didn't actually source that part. I actually don't populate this part of the board.
Okay. Yeah, it would be maybe a feature that you can test on in future revisions or whatever.
Yeah. I don't know if anyone else does that, but I often want my boards to have the things that I might have not tested or the next iteration.
Yeah.
And I kind of did that with the SD card reader. Last minute, somebody wanted an SD card reader.
Okay.
And I said, well, I probably need some decoupling capacitors right near it. I didn't add them. I just threw it on. So
yeah, usually you have maybe some pull-up resistors, series damping resistors on the clock line at least. It looks like you just kind of connected them directly, right?
I did. Okay.
And if it's just short routes that aren't really messy, it's probably fine. But you can test it with this and see what happens.
Yeah. So it's probably not on this board, but at least I have it there. And I did add for the first time ESD protection, which I usually don't do, and I knew was standard.
Yeah, this is nice to have, so you can protect the board from getting zapped when you plug in the USB.
Yeah,
it doesn't happen very often, and a lot of times the microcontroller will have at least some protection on it, but it's always good to have those.
And it's a bummer if you only have 2 of these devices in the world, and then you'd have to wait like a month or 2 to get the new parts.
Yeah, that would be kind of a nightmare. It feels like the ESP component could almost be like just like a module that you plug onto your board, and then that way you can decouple and get like a little more standard module. You just plug it on there and off you go. But I guess the form factor doesn't really work well for, having like a lot of extra stuff like that.
Yeah, and it's a wearable.
Yeah.
So when it's all done, it's about this size.
Yeah.
And so part of it is just the mechanical harness. And so it ends up being pretty small
Okay.
and pretty
Yeah.
populated.
Yeah, that might be a little tough to get like a module on there, but yeah, you want it to be flat, like less thick this way, right? So it's probably better to
Yeah.
do a single board. It's very nice. You laid it out quite nicely.
Well, thank you. Well, and you
Turned out
helped me.
well.
I never had done 4-layer PCBs, and
Okay.
you were encouraging me to do 4-layer, which
Yeah.
I needed for this design. There's no way I could have gotten it this small.
Yeah. 4-layer is good for signal integrity and power management, and routing is so much easier. Um, a lot of times there's no reason to not. It's better to cost and do a 4-layer. And when it comes to like huge production or whatever, yeah, it's better to have um, the 4-layer PCB in the long run. And if you ever want to get it, certified, like FCC certified, it's gonna be a whole lot easier to do with a 4-layer board than a 2-layer board, if you do it right.
Yeah.
So there's still probably some work, some room that where you could add more filtering and kind of stitching vias or whatever you need. Thing is, FCC is like only when you get to the point where you're trying to sell it, and that's kind of pretty far down the line, I'm assuming, unless you just plan on putting the files out there and having people make their own. Yeah.
And there are people that are interested in doing that. And I post all these files are live on the GitHub now. So every revision that I do, for good or bad, I post on the GitHub repo right away.
Okay, cool.
So people can download this now. And I did fix a couple of things. But I actually had to have this board manufactured because of this one part. I can't solder this IMU, this gyroscope.
Okay.
Because it's underneath, and I knew every time I solder these myself, solder reflow, I always messed it up. So I literally paid for the board to be partially assembled just for this one part.
This helps. Actually, I typically do like protos by hand, at least when I can, and I use a solder paste transfer method. It's just sometimes that it's just not, even then it's still not easy. If you don't have like a toaster oven or like the reflow oven, doing it with a hot plate might be an option, but the hot air, sometimes it just blows the chips like around when it shouldn't, and especially on tiny ones, and it gets really frustrating. I'm assuming, is it single side population, or did you put parts on both sides?
Both sides, yeah. And I will pull up just so you guys can see the schematic again.
Okay, let's go ahead and put that up.
Yeah, so the front side has most of it. The back side just has the haptic feedback, the multiplexer, the ESP, and then the SD card reader.
Okay.
Yeah, and I don't populate this circuit usually.
Okay. Yeah, it doesn't look like there's a ton of components on there. It's nice and compact though.
I tried to, and I didn't necessarily adhere to the standards, as you can kind of see the vias and how this multiplexer is set up. But I'm still a novice when it comes to these boards. But
it actually looks pretty nice. I don't see it being too squirrely there. As long as there's a plane to couple the trace to. I'm assuming green is ground on this.
Yes, green is ground here, and that's the second layer. And then I have 3v3 on orange, and I did just trace VBAT here.
Okay. Yeah, I think that if you have some like high speed signals passing over splits in the plane, you're going to have problems. But it looks like you have most of the traces there coupled to a plane. So I think you're doing okay in that respect. I see a via in pad there. You use the smaller vias on, it looks like U5. Those
Uh,
vias in the pads can actually cause some grief.
oh,
Thermal or solder thieving from the pads.
oh,
Components.
interesting. I did not know that.
Yeah. So if you don't plug the vias, there's a chance that the solder can wick down into the via and starve the connection on the pad, or sometimes it'll actually cause the part to do a tombstone. So you'll see the part like flip up on its end and like
Yeah.
it'll be stuck on the one side that's not connected. It'll just be dangling there. And yeah, when you put vias in pad, it's recommended that you plug and plate them or use yeah, buried or blind vias, but you don't want to do too much of this uh,
Yeah,
kind of
because
stuff because it's expensive. So I'm assuming those are tiny vias. Uh, did you use PCB Way for the manufacturing?
I use JLC PCB.
GLC, okay. And four layer, it looks like it's standard, but those vias look pretty tiny. Did they say anything about your vias or?
No, they
Okay.
didn't, and they kept them as is.
Okay. What size is the hole on the vias?
Yeah, let me see here. Looks like it's point 0.3.
0.3 millimeter.
Yes.
Okay. Yeah. So, hey, look, some people are out there yelling at us.
Oh,
Is
nice.
that you? Is that's probably Fixer?
Probably.
Yeah.
Yeah, yeah, we're live.
We actually jumped on, and if anybody else wants to jump on, that's cool. But we're kind of talking PCBs right now. Uh-oh. Use next PCB. Post on DevEco, of course. Yes. Do you know anything about DevEco? Have you been watching the kind of the progress going that way?
Are you asking me?
Yeah.
I joined your other stream. I only caught the second half of it after
Okay.
you reached out, but no, I've been a little oblivious.
Okay. Well, so the deveco.io, and then from there we have like a bunch of hubs, and then you can go to the Devosh hub and share your project there if you wanted to, and that way we could have more projects shared under our initiative.
Yeah,
Um, and if you would just want to share it as your own, that's fine. And the process is pretty straightforward. If you need any assistance or guidance on there, it's kind of like Hackaday IO or Hackster IO. Um, it it's just kind of a basic form you fill out. It kind of guides you through the process. You can add some pictures and talk about the project, but most importantly, share links back to GitHub where you store the project since it's open hardware, right?
that is correct. Yeah, I will
Um,
definitely add it there.
awesome.
I got it
Woo-hoo.
bookmarked.
All right, deveco.io. Excellent. So I guess yeah, the kind of the this IC1 is the accelerometer
Yep,
gyroscope then? Okay. Yeah, those
that's
are pretty tiny pads.
yeah.
Yeah,
And
and you
again, I
see,
have this via right next to it, which maybe isn't that good.
yeah, they see that one was you actually have the via in the pad, and that's a ground pad, so that could thieve solder from that pad into the via, causing a no connect, causing your board not to work and making
Okay.
everyone sad. So
Yeah.
if you do have vias inside the pad like that, usually you want to do plugged and plated over pads or vias. It costs extra though. I think it comes standard with the 6 layer support, but it doesn't with the 4. So you have to pay extra. I
That
think
makes
with
sense.
JLC at least, but I might be thinking PCB Way. I know that both of them will support it if you ask.
Yeah, I haven't gotten to those advanced things, so that little tip is helpful to know, and it makes sense because I know that I get frustration with uh my my brain knows that these right here. That's why you have this plus sign.
Yeah,
I,
that's the thermal spoke, so you can unsolder the part.
yeah, so it's
It
kind of
doesn't
the
want
same
to be wrong.
principle for the vias.
Well, yeah, when you pull the vias like to the side of the pad, they don't they're not going to be in the pads where the solder is going to be resting when you do the paste application. That way, there's no way for it to go down the via with the solder and kind of ruin up the connection. I've seen people get away with it with larger components, moving all the vias that can be off to the side of the pad, just slightly off the pad under the solder mask, so you don't have any solder thieving issues.
Yeah,
Yeah, and I can add a ticket to your repository if you'd like, or doing that
yeah,
in the next revision. Sound
yeah,
good?
for
Okay,
sure.
cool.
Any of
Yeah,
these little tips is very very helpful.
yeah. I like to do like kind of like the basic design review, um, kind of offline, so that I can kind of look at it closely up close and kind of pick out different things. I know that we went through the process a couple times, but there's always room for cleanup and making things nicer, and I can kind of try to find some of those. It looks like the USB routing might be a little squirrely.
Yeah, the USB here. This is where it connects to
Yeah,
the.
I see the data lines are separating, and this is not good. Yeah, you want those to be routed as a differential pair.
And I didn't do that, and I'm actually looking in because KiCad allows you to do that. And by differential pair, you mean that they're the exact same length? Is that
Yes,
correct?
and they're on the same layer. They transition layers at the same time, and they're spaced within a certain distance of each other, and it'll give you a characteristic impedance for the differential pair that you want to kind of match for USB spec. So you probably want to do maybe a little research on how differential pairs work.
Yeah,
But I think as long as you, for a lot of microcontrollers, as long as the wires are there, it works. But if
yeah,
you go to try to like do EMI testing on this thing, it's going to probably squawk like crazy. And it's better to keep those traces closer to each other and coupled. So like when it passes through the ESD diode, it,
yeah.
does this that's interesting. Because usually you have to pass the line to 3 and 4, and it passes through. Does this the interface is working though, right?
It
What,
is.
okay,
Yeah.
what chip is it that you're using there? U5.
Let me check real quick. Um,
Okay,
I actually have to pull up.
is that like a LCSC?
It is. It
Okay,
is. Let me pull up the BOM real quick,
okay.
and I'll be able to tell you. Because I know I switched it because I actually used KiCad's built-in JLC PCB add-on to get the BOM, and that was
Hmm.
actually helpful.
Yeah, yeah. So I think those two are kind of hand in hand. GLC and the LCSC kind of they stock one another, right? So it's like
Yeah.
for partners or whatever, and you don't have to go searching around because they can source the parts for you and put them on there if you get them from there.
And what was that? That was U5.
Yeah, U5. So usually you have a pass through and it just attaches diodes to the lines instead of having like a break in the line.
Yeah, this is just some LCSC part.
I'm guessing since it shows the trace through the middle, it's probably got the continuity through the middle of the part. So it's just different than what I'm used to seeing, like a TI part that I use,
Yeah.
but it routes a little differently.
And it did, and I actually had to rotate the device, the IC, 180
Okay.
degrees, and it
Yeah. Can you
made it
zoom in
work.
on that schematic on that thing so we can see
Yeah,
what
because
we're
the
doing?
schematic the picture diagram was wrong.
Oh no. Oh
Yeah.
no. Yeah,
So
the layout, yeah, as long as you follow the design notes, that you're probably all right. But yeah, it looks like they just kind of, okay, yeah, you don't have to actually pass the line through. It's kind of hard to see on the tiny
yeah,
screen here.
sorry.
It's all right. Um,
But what ended up happening was that 5 and 2 were switched. And
ah,
so I ended up ordering 10 of these, and I just rotated them around.
okay,
And it did end up working. So I changed it here. So I think this diagram is technically wrong.
okay,
But I just need to replace, because this is just a symbol in KiCad. But
okay.
I put this here. Version 4 had wrong orientation, fixed in version 4.2.
Okay. Well, that's good that you took note, and then you can fix it later.
Yeah.
Make sure that we're doing everything correctly. But yeah, it kind of stood out a little bit to me. So that you've tested all the charging circuitry and the
Yes.
power and the accelerometer and of
Everything
course the
works,
grid.
except for I'm having problems with the charging circuit.
Hmm.
It's set to 500 milliamps
Hmm.
charging,
Yeah,
but it is not fully charging the battery. It's maxing at like 4.01 volts.
interesting.
And
Yeah,
I'm not sure why. And I think it's because I usually use standard parts. And I've used this exact power setup in 3 other boards, and it's
okay,
always worked.
okay,
And
interesting.
and there isn't much changed other than I used the 4054, this STC one, but I wasn't sure why.
Interesting. Yeah, it looks like yeah, I'd have to look at the data sheet, but it doesn't look like there's a whole lot of tuning there. Like it's specifically for single cell lithium polymer.
Yep, yep,
Okay, yeah, interesting. And you got a 2K
yep, for the
500.
program. And so this should make it 500 milliamps.
Hmm.
And when I plug in the USB, it also turns on the device.
Hmm.
And when Wi-Fi is on, I know that can draw like 100 milliamps, but
Sure.
it's 500. It should be well above that. It should be charging, but I kept it plugged in on my computer, and the green light here never goes off. But I plugged it into a high wattage charger, and it eventually went off after like 5 hours. But something is wrong, so I'm not quite sure.
Yeah, I would check. I would check all the connections. Can you select that on the component U4 and then see what it looks like
Yeah.
on the PCB side? Okay. Yeah. So we don't have any vias in the pad here. Your ground is floating, isn't it?
Oh no, it's just
Okay.
one of the pads is on ground. Yeah.
Okay. Yeah. So that pad might be a little low on solder, so you might be able to like add a little more solder to it if it thieved the solder and made like a poor connection to ground or something. That might cause it to not work as well.
Oh yeah.
So I would check that out. And it looks like B bus is coming in there. B bus trace looks okay-ish coming from that way, and then you got it looks like trace coming up to the north of it. What is it going to, like a resistor or capacitor? Okay, that's the LED, right?
Yep. D2 is the LED.
Okay, and it's coming back around to from B bus to that signaling pin, which is the charge enable pin, right?
Yes.
Okay, so you're saying it's always on.
The green light is almost always on. If I plug it into like a 60-watt USB charger, it will eventually go off.
Okay.
And so I was just surprised. There's no PD or anything, right? So
No.
I'm not sure why that's the only way that it can fully charge. But
Okay.
Even then, when I measured the battery, it only looked like it was 4.05 volts. It doesn't look like it's getting close to 4.2.
Yeah, that's interesting. Um, for the, let's see, do you have the pull downs on the USB connector that give you the appropriate current?
The pull
You
downs, I
don't.
have the
Oh,
5.1
there they
Ks.
are. There they are. Yeah, so that'll give you 1.5 amps, I think. Something like
Yeah.
that.
And I also have the one that I plug into my computer is a powered USB hub, and
Okay.
I can even measure the output, and it usually measures pretty high, at least 500 milliamps. So
Okay. So that's more than the ESP is drawing. So it is charging the battery. Just it's not charging it all the way to the top.
yeah,
Interesting. It's probably doing something towards the end of the charge that's kind of slowing down so that it doesn't overcharge the battery and cause problems. There might be some kind of issues with that chip or the solder connection on some part of that chip. Trying to reflow the ground might help, but
I'm
I'd have to kind of
yeah.
put the scope to it to see if we can find anything otherwise. You might be able to see kind of um, some some hints by probing around with an oscilloscope.
I can do that. Yeah, because I do have an oscilloscope, and
Yeah.
I would
So
like to know before I make the next version.
yeah, kind of. Yeah, that's the trick is to figure out as many things as you can with the current version because the next one, yeah, you don't want to like keep kicking it down the road. Try to wire mod the corrections onto this version and then verify them and then make the new board.
Yeah.
Because it's a lot of time and cost to keep doing iterations. So it's pretty nice considering it's your like first major PCB, right? Like
It is.
you're it's been a lot of iterations of the same one, but it is
Yeah.
first
And
one.
I actually, my label device, which is the one you help with, uses the same setup, same microcontroller. There's
Mhm.
a different sensors, but
Hmm.
essentially I'm borrowing all these components for each
Yeah,
one.
it's good to reuse the what works and you keep using it, right?
Yeah.
It's a good way to go because that way there's a lot less unknowns and less possible pain when it comes time to figure things out. It looks like you got some row and column connections there. Is that for all the different grid on the armband?
Yes. And so this is just the multiplexer and then the ZIF connector.
Okay.
And so that was probably the hardest part for me was actually designing the male FFC connector. Just
Okay.
because it was kind of scary. You just have to read a data sheet because usually you buy male and female components, but in this
Yeah.
case, you buy the female component and then you have to design the male as a part of the PCB.
Yeah. Yeah.
But
That can be a little nerve wracking, I guess.
it
But
was.
you have the stiffener part, like the back piece has to be just right, otherwise it won't hold into the connector.
Yeah. And that's where JLC PCB was kind of nice because when I first ordered this, they kind of were they were hounding me, telling me that wasn't gonna work it onto, even though that was a bad idea for a different reason. 1 second,
Okay.
trying to get this on.
Oh wow, that's
And so yeah, I was just trying to solder it onto the board, and that didn't work. And we'll just pretend like that never happened. But
you can tack wires to it and then tack those wires to
yeah,
yeah.
I was doing that with a microscope, and it was
Oh
part of the solder or wick, copper wick,
yeah.
the little wires.
Yeah, you need to
But
have really steady hands and some flux, a lot of flux.
yeah,
If you're not good, like if you haven't practiced under a scope for the fine pitch stuff, it can be a little tough. Like most people don't have the hand-eye coordination to pull it off. least get frustrated with it and put it aside. But it's better to do it the right way and get the connector and solder it on. It looks like you did exactly what you needed to. So it looks like a keyboard almost, right?
Yeah. The one thing is I lined these up by hand. I actually used CAD software to overlay where these pads needed to go.
Okay.
And the wiring is wonky because I don't know how to do angled wires in KiCad, or KiCad.
Yeah.
But I was proud of these component. Yes. These are the main sensors themselves.
Cool. And that I'm assuming there's an opening for those, like, or is it just like a capacitive type situation?
Yeah, so this is, exactly. It's just measuring the resistance. So these two don't touch.
Okay.
But where the velostat touches them, what's nice is that we're just increasing the surface area. So anywhere that pressure hits here, it's going to measure.
Okay. So it's just like and it's like a contact switch.
Exactly. Yeah, contact switch with measuring variable resistance.
Yeah. Okay. Yeah.
And I don't need to ground this because there's really no ground, but I added it mostly just for the rigidity of the flex PCB.
Yeah, I see the grid in the back there. Use that a hatched polygon pour.
Which again, it was just, this is more of just a test. I probably have to rapidly change the shape. Again, this is probably the weakest part is this flex, even though it is the main sensor itself. But, and these are just curves that I placed, which maybe is not ideal.
Yeah. There's ways to do off-grid or direct routing, curved routing. You just have to go through the which version of KiCad are you using?
10 right now.
Oh yeah, you should have all the things you need. It's just figuring out the buttons to get it. Yeah, you want to fall off the grid and the orthogonal grid and use like kind of direct connects for the traces. I forget what you have to press to do that, but there's a way to do it. I'll see if I can find some tutorial or something that kind of shows how to do that. Or if there isn't one, then I can try to figure it out and let you know, because I'm kind of interested. I usually only use like weird curvy traces in like artistic or boards that really need it, like circular boards or things that are really kind of oddly shaped. But yeah, there's a way to do it. We just have to turn off the orthogonal locking or whatever that puts the grid like 45 degree or 90 or whatever.
I love KiCad or KiCad, however you pronounce it. So I
like everybody pronounces it differently.
It's just so amazing that it's open. I think it's open source, if I'm not mistaken.
Yeah.
That's just beautiful because that way anyone else can download this and then tweak it. So for open source, I think it's just amazing.
Yeah, it's come a long way. It's been years and years in the making. Oh, so he's saying you're open source. Are you open source now?
Me?
I guess you are.
Yeah.
And yeah, it's cool. Everybody should do it.
Yeah, open source hardware. One of my devices is registered. I have a OSHWA
cool.
certificate.
Nice.
Or number.
Yeah, you just get a number. It's self-certified. You have to conform to the standard, meaning you've got an appropriate license, bill of materials, design files, et cetera. But I think they don't hawk it that much, so people could probably sneak in like less than open things, and if you see them, you should probably say something. But a lot of times it's just Adafruit or SparkFun doing the registrations.
Yeah.
Yeah.
But that's kind of it in a nutshell.
Cool.
The multiplexer, the only last thing I would say is that my capacitor values were too high. And so when the multiplexer was switching, the capacitor kept the voltage high.
Ooh, okay.
And so I switched these to 100 picofarads, I think.
Okay. Yeah, is there a reason why you
fixed it.
need those capacitors specifically?
I thought it smoothed out the signal.
Okay.
Because usually you have decoupling capacitors next to the ADCs on other sensor types.
Yeah, yeah. So those S0 through S3 is the
ADCs.
Okay. And E, how does this thing work? I'm trying.
Oh, this multiplexer? Yeah. So you give it the binary value of what of where to send the signal. And so I think what I'm doing is I'm taking 3 volts. GPIO 16. I have to think for a second.
I see it on pin 9. So just is that
That's just telling it it's on, I think.
Oh, okay. Enable.
Yeah. So that's what I'm doing. So I'm just sending 3v3 to all of these columns. And so I'm always reading the rows.
Okay. And the rows you're reading the rows digitally or?
Yep, digitally through the ADCs. And I do have these resistors on them. So that way I end up measuring the resistance. So these all have a 10K pull down.
Okay, so it's got like a filter on it.
Yeah.
Okay.
And these 10K resistors allow me to reliably read the resistance of the velostat. So essentially the pressure.
I see how it works. It's a voltage divider.
Yeah.
Okay.
And so applying 3v3 with these going down, then it gives me a pretty good signal.
Okay.
But that's the meat and potatoes. Yeah.
Awesome. Yeah. It'd be cool to kind of see the signals in action, or
yeah.
You have like a demo you can.
Yeah, I'll just show you. I'll just show you the live heat map of one of the bracelets. This actually works in VR too.
Neat. Yeah, I saw a video. The last video showed that.
Yeah.
Do you have a link to that video? I can.
Yes, I do. I will share that real quick.
Actually, I might actually have it on the live stream. Yeah,
I think it is on the.
Yeah, I got it. Let me grab it.
Sweet.
You can work on your side with bring up.
So I just got to turn on the device. Hopefully it will auto detect here.
Come on down. So
there we go. So now you can see this is it working.
That's cool looking. That's really cool looking.
So this is me not touching it, and you see the IMU unit rotating there too.
Yeah. Oh, cool. Yeah, it's dynamic. It's working.
Yeah.
Is that a web page hosted on the device itself?
This is actually hosted on my computer.
Okay.
And it's because I'm actually doing machine learning. So below here, these are the different models that I've trained. Okay. And I usually record both hands at the same time. And I also record a label device. So I'm going to turn on my label device, and you'll see that. And that's over here.
Okay.
And so I usually pair a sensor with a label device. Either the VR is using the visual visual model of the hand as a label, or I'm using this piston mechanism.
Yeah, that gives you kind of some more immediate feedback. You don't have to do any magic machine learning to figure it out.
Yeah.
Which is nice. So you have two apparatus that are connecting back to a server on your PC, and then the PC is doing some AI magic or machine learning.
Yes.
And then kind of giving you this graph here.
Yep. And so
It's pretty cool.
mostly records until I hit this inference, which I think I can actually, it is predicting, but it's going to do a horrible job because it's not on my arm at the moment. But what's crazy is I only need about 2 minutes of training data, and then it can predict which finger I'm pressing.
Oh wow!
Yeah,
Based on just on the readings from your arm.
that's correct. Yeah. So
It's
once
really
I
neat.
label it with about 2 minutes of data, like 1,200 samples, it can predict each of the 4 fingers.
Okay.
And I'm only sampling at about 20 hertz.
Yeah. So it's like I'm wondering how we train this for somebody that, I mean, they're moving the tendons, like they're thinking in their mind that their hands moving, right? There's nothing moving there, but it'll still have movement in the forearm.
Yes, if it was a recent amputation, or it will, when you move your fingers, you automatically contract those muscles in your forearm without thinking. When you
Yeah.
just think about moving your finger, um,
Interesting.
so this will pick up off of that. So it should allow somebody to just try in their head to move their fingers on their hand, and this should be able to pick that up. You would
Interesting.
likely have to train off of a virtual hand, or
Yeah.
you'd have to have them mirror, maybe wear 2 of these bands, and that's why I made 2 of them.
Yeah. I see what you mean. So that like you're the like kind of like doing it in unison to
Yeah.
mirror it in your mind, like the actual movement, and that would kind of make it more uniform. Like, and like for one arm, that it's actually you can actually check the feedback and check the signature. Assuming the signature is slightly different depending on kind of the person and kind of the atrophy of the arm, I'm assuming.
Yeah. Yeah.
So,
And also the amount of fat that you have over the muscle tissue.
right. Yeah,
So
that's
there are some things that we have to overcome, but I'm actually working with a gentleman in Oregon that will maybe try this on an amputee in the
okay.
coming months.
Yeah. Well, I'd like to see how this goes because that's really kind of it's pretty awesome to see it actually like being used for its desired purpose, and
Yeah.
hopefully, experimental results kind of confirm it and make it, see if it's viable to the point where it could be deployed for more people. I know a lot of the other tech uses like detecting of the nerves, like
Yeah.
it's a little more complicated, but that's probably why it's so expensive and it ends up staying in the lab.
True. And the signals are higher frequency, meaning that you have to have higher sampling rates, which means you have to have higher computational costs for inference or actually, deciphering the signal.
Yeah.
And so I hope that this is a novel approach. And I plan on actually, I think I have funding already secured to send this for free to multiple colleges to
Oh,
just
cool.
say, hey, here's free open hardware devices that you can test.
Cool. Yeah, get it out there. Get some smart students to take a look, maybe make it better. I think
Yeah.
that's kind of the trick, right? This is one of the benefits of being open hardware is that you can openly collaborate with people that may or may not be smarter than you and can figure things out a little better and make it even better than it was. Then again, it could also just kind of sit on the shelf. It really depends on you when it comes
Yeah.
down to it.
That's
That's
why I'll
really
try to drive it home. And that's why 4 years later, I'm still working on it.
well. I'm glad that you're still working on it because it's a cool idea.
Well, I'm glad that you created a platform today and also are willing to do the hardware, looking that over, because not many people are willing to spend that time. So
Yeah,
I really appreciate what you've already done for me. So I just wanted to thank you again.
cool. Yeah, it's no problem. And I kind of do this for a lot of people actually. Simple design review, like design by Twitter. When I used to be on Twitter, people would post their designs, and then I'd be like, okay, yeah, you could probably do this or that. And I've even had other people review my designs, and a lot of times it's kind of nitpicky or small things. But I've been doing PCBs for a long time. I like to have a peer review, even if it's just anybody looking at it, because that makes me look at it from another angle and maybe find some things that can be improved. Hardware, you kind of have to let it, like after you kind of gotten everything into it, and you're like, you gotta let it sit for a couple days and simmer and not order anything. Just make sure that you didn't forget something, and then order the parts and kind of give it a try. I think like it takes a lot of patience and a lot of attention to detail, and yeah, a lot of people just kind of they fall out of it pretty quickly because of how much effort is involved in completing the loop. But
Yeah.
having resources out there for people is kind of important. And when you give them like something to start from, it's a lot easier than saying, "Hey, just make this and come back to me." Hey, here's this thing that mostly works. Hey, take that and make it into something that fully works. Experiment with it. And you don't have to be an electrical engineer to do printed circuit boards, but it does help a
Yeah.
lot.
Well, I just know when you were reviewing my designs, it made me want to work harder on them because I knew they would be looked at. And
Yeah, I think
so,
that's important part of it. And this is the same thing that happens upstream when you're doing open source development. You have you have some fancy maintainer like that's reading this code. I better make sure that I did it right.
yeah,
you know. So
it's public, so I don't want to make a fool of myself and have egg on my face.
well, yeah, it's like there's degrees of egg on your face, of course. Like on Beagle Wire was one of the projects I worked on. It was FPGA board. Apparently, we got through the whole project, and after the fact, found out we put the PMOD headers on upside down, and so you had to plug all the PMODs in upside down to get it to work. And yeah, they're actually stocked at Mauser that way. It's kind of sad, but
Really?
this kind of happened. And sometimes it was a Google Summer of Code project where I had a student that designed the board, and I actually did kind of like multiple rounds of review and missed it. It's always good to have testers on the first like couple batches of them,
Yeah.
so that you can catch this a little earlier. I think we might have just said, okay, just flip the PMOD upside down and don't worry about it. It's not that big a deal. But it is kind of a big deal because it's user experience thing, and but I've seen people use them still, and they sell multiple units. So yeah, apparently you don't have to be perfect, and you can get away with small things sometimes. But it's always good. The more people you have working on it, the more you'll find these things. And that's how we found it. Was somebody was making another project based on the board, and he saw, oh wow, these connectors aren't quite right. And he actually made a little adapter board that flipped the lines around so that it was facing up. It was pretty nice. And yeah, there's a lot of room for like improvement on things that are like kind of put together for like a summer of code or whatever. That's not a long time to bring up a printed circuit board, write a whole bunch of Verilog, a whole bunch of driver code. We did a lot in the order of like one semester, and I think it turned out pretty well, all considering. How many testers have you gotten this thing out to so far?
I actually made 10 units and I'm going to ship out some tomorrow.
Okay.
Some to Germany, some to England, one to Oregon. So there will be
Awesome.
3 other people than myself testing
Awesome.
this.
Excellent. That's good. That means there more eyes makes all the bugs shallow or whatever, as they say.
Yeah. And I'm sending them for free essentially too.
Yeah, that's
Just be,
nice.
because it's my passion project, and the fact that people want to help, I'm just excited,
Yeah.
But ultimately, I'm just glad that if anyone else is watching, aspiring to design a PCB, it's very fun. And I think that there's something, especially I was just a Python programmer and
Yeah.
a IT guy. And the fact that I'm able to design stuff it's just very enjoyable. It almost is as enjoyable as video games, but I don't think people believe me.
I
But
think
it's
it
true.
really depends on the person and the type of video games that you like.
Well, Satisfactory is the one I'm playing right now. I don't know if you played
Okay.
that before.
Satisfactory. Okay. That's fun. All right. So I think we've been on for about an hour now. I actually wasn't expecting it to go because I totally missed the start window on the, so we missed out on all the updates from Pixar and Kevin from Delta. But I'll try to get them on the line before we get out to. We're all going to be at Open Sauce next week. So if anybody's watching, you might see us out there at Open Sauce next week. See the Maker Chip in person. Yeah, maybe get some cool swag. I think there's some T-shirts that might have been made for Devico.io. Got to get you one of those probably, especially if you post your project there. This
I
is
will.
a
I
requirement.
will.
And yeah, if you have any questions, just ping us on the Devico Discord. Um, yeah, so I guess we can call it for this week. So anything happening out on the? Oh, we got some spam, and from the Twitch stream. Yay,
Oh, that's always.
Spambo. Yeah, I don't think the Twitch is kind of the place for techies. It feels like it's just there for gamers, and there's a few techies, but mostly just people kind of doing weird video games or ASMR or whatever it is. It's just kind of, it's a different crowd. And I
Yeah.
don't like the commercials especially either.
I haven't found a good place to stream other than YouTube for when I'm doing tech stuff. But
Yeah, we're trying to fire up the Bevy stream thing, but it kind of it we're putting like a lot more effort into the Devico.io, and I think eventually they're going to actually merge platforms, so it's going to be one platform to rule them all, kind of thing, in the long run. And a Fixer could probably he's gonna we're gonna have like an official launch for Devico.io at Open Source, so then we can
awesome.
start talking about it more, and you'll see posts on LinkedIn and people starting to kind of get excited about this new platform, which is it's what's really special about it is it's all community based. There's no company like forcing their hand or saying you have to do this or that. It's all community run, which kind of it's pretty unique. And I mean, the medium isn't that much different from some of the other sharing sites, but a lot of the other sites are wholly owned by some corporate entity, and they kind of have reign over it. So
Yeah. I
yeah,
think that's beautiful. I honestly think people that are into open source and open hardware have the same kind of ethos, at least in my experience. I think
yeah,
they're all great people that you want to hang out with.
yeah. There's the purists, ones that want to do it without any AI, and they're out there, and um, there's the ones that are like AI agnostic, like myself, and then there's people that don't work without it. They don't work without it. Essentially, that's how they work, and it's just what they got used to. But I mean, if you're getting things done and it's benefiting humanity or whatever, I guess we can burn whatever amount of diesel or whatever they're doing to get the AI to work.
The carbon
But,
footprint increase.
yeah.
Yeah.
Yeah, I think there's going to be a pretty big reckoning here pretty soon where AI kind of, yeah, has
Well, I
a.
won't tell you what my job title is then.
You're an AI guy, aren't you?
Yeah, I'm a lead AI engineer for a medical company.
Nice. Yeah, I see. The thing is, like, I grew up without it, and I got to where I am without it. And then the last couple, like 4 or 5, 6 years, or however long it's been, it hasn't been that long. It just seems like crazy fast how it developed. It feels like I'm kind of, yeah, getting replaced by the machine or whatever. But you're really not. It really comes down to you driving the machine.
Yeah.
And I think people need to use it a little more, cautiously or effectively, not just spam the tokens or whatever. But otherwise, yeah, it's a
It's a
tool.
tool. And I
Yeah.
think, you know, like I make it akin to like a drill that can spin at, 10,000 RPM. Like, well, that's cool. It's a drill that can spin at 10,000 RPM. Doesn't mean I'm going to use it to screw in a screw, right?
Yeah.
Just strip it. But there are uses where it is helpful. And so I have AI help me to look up data sheets for when I'm doing the PCBs, but it will error. It will give me errors. So
Oh,
I mostly just have it do some of the quick work that I have to double check.
okay. Yeah. Yeah, I think that like anything that like that you could do, it's just going to be kind of like a repetitive, boring task. These kind of things are really good for AI because it's like, oh, repetitive and boring is my thing,
Yeah.
It's like I can follow the pattern and I can do it consistently. In person, like they sit down and they do it like 1,000 times, they might miss one, and then it's like takes like a month to find that problem. So, yeah, refactoring is one thing that I found that like the LLM tools can help a lot with. I'm kind of getting pushed into it. I work at Samsung, so AI is kind of a major thing in the industry, and there's a big push.
Yeah.
Um, so I have to learn it, even if I don't use it. I need to know how it works. I need to, effectively communicate with people that are using it. And I also have to deal with all the AI agents that are running. They're everywhere,
Yeah.
it's not like you can get away from it anymore, um, unless you're, running your own infra, essentially, which nobody does. Like, unless they're a huge company. But then the huge companies are the ones trying to push through this AI stuff. So they're like dog fooding it like crazy. And like
Yeah.
token maxing or whatever the hell they call it. This to
I
me feels like a stupid trend that's going to cause nothing but grief in the long run. You
you
should
know
think
it
about your tokens, like use
it
them
is.
wisely.
You should be doing the opposite. You should be token minimizing.
Yeah.
And I think that it's just like any tool, like I don't know, a compiler. Like, you know, uh, the,
Was this time worth burning down that tree
yeah.
or whatever?
Yeah.
Drinking up like, everybody's water. Was it
So
worth it?
I
Yeah.
have my own AI tool that's my, persistent memory, and I spend $3 a day on tokens.
Okay. That's
And
not
so,
it's not a lot at all.
no, I have a cell phone app, I have a web browser, PC app, and all it does is it just keeps track of all my stuff. And I built it custom, and I can run it on less than $1 a day. But if I want to be fancy, I go up to 3. And to
Yeah.
me, I don't
Three
think
dollars.
anyone needs to do any more than that.
Yeah. Well, you don't know everybody.
True, true,
Some people
true.
have a lot of technical debt to wade through. They have a lot like of work that backlogged, and they're swamped. They're over their head and they need a leg up. Because okay, so I work at this big company, and half of my colleagues were cold. under the guise of, AI advancements or whatever, and then your workload just goes bonkers,
Yeah.
and like, I'm not saying this from personal experience, but in the industry, like, it's going to have a huge like backlash. It already kind of did, because there's a lot of people just misunderstanding the tech, and just kind of like, oh, this is the new thing, and we don't need engineers anymore. We just press a button and tell it what to do, and then it's just magic, and like everybody's like job's done and get free lunch or whatever. And then turns out it just causing a massive imbalance.
It's a good way of putting it.
Yeah. So, oh well.
Because they're rolling
Eventually,
back.
it'll come back. It'll come back. It already has, but it could get like, yeah, yeah. A lot of people do use AI wrong, as Pixar was saying there. It's just they're not putting their knowledge base into it, and they're not correctly guiding the machine to the solution. You gotta be very specific about what you want it to do, and also what you want it to actually look at in order to do it. You can't have it go, off like hallucinating things. And this is where it gets really weird, because I don't know where AI comes up with these things sometimes, but it's like, especially
Yeah.
in documentation of your code, it's like it just makes things up, and you have to go back, and you have to say, no, this is not what this means, or yeah, it's
There's
just
almost entropy runaway. So
yeah,
like if it makes a 5-page document and it has one small error, gives somebody the wrong name, and then they
yeah.
use that document to populate more documents, and what
People
happens is
perpetuate it.
it expands and expands. It's like an error on a hard disk, that like a bubble. It
Yeah,
just
it's not good. Yeah, the drift. All right, so I guess we can probably call it. Do you, Pixar? You're out there. You want us to cover anything else before we jump off? Sounds like he's sort of listening back there.
I bet.
Yeah, I usually have a. Oh, well, feel better. Yeah, you don't want to come on the air if your throat is killing you. Just make it worse. Yeah, we know. We'll see you next week. Do we want to do a live, like kind of live from open source, Fixer? Something cool like that? You can't get people sick through the internet. What are you doing? No broing. We're definitely going to have some kind of live stream on the 19th. Okay, cool. Excellent. Yeah. Awesome. Booth crawl. Those are fun. I think last time we went to Crunch Labs, and a couple of like the Delta Robotics. They're really cool, and they're going to be there. Kevin, and he's kind of like the maker chip guy. He's going to be there. Have you met Kevin yet?
Yes, Kevin, I did a little interview with them on their artificial muscles from back in the day.
Yeah. Of course, there's all the YouTubers coming to the show.
Yeah.
He's got a long list though. People like, yeah, we know a lot of people that are going to be there, which is fun. At least he does. I know them by proxy.
Well, thank you
All
again
right.
for having me on. I
Yeah.
appreciate it.
Yeah, I'll put a ticket in for your for taking the vias out of the pads, and maybe I'll look at the schematic and PCB a little bit for you
Thank
and
you.
add some tickets. And yeah, if you have some like interesting progress on the project, or you want to share again, you can jump on again, and we can do this one more time. All right. So
Thank you.
for this week, thank you everyone for joining us. It's been a good one. I started out kind of slow, and I'm sorry about that, everyone, but we had Tori show up. All right. Good night. Oh, yes. Oh, wait. Don't forget to post the IO hub. Yeah. Tavico.io. It's not gonna let me do that. Let's see. Last minute links.